Kia ora, Ben, Tosef and Snehal. Here's another coordinate geometry question. So in this one, we're given coordinates of points A and B, but they're in terms of K. And we have to find the gradient, and we have to show that it's independent of K, so that's clearly a pretty easy question. And then we have to find the equation of the perpendicular bisector of AB. So just before we get going, we should know that if we've got 2 points A and B, it's pretty easy to find their gradient. To find the perpendicular bisector, remember we need to find the midpoint, and then we're going to use the fact that gradients of perpendicular lines multiply to -1, and that's going to give me the gradient of that line. So then I'm going to have a point and the gradient, and that lets me find the equation of the perpendicular bisector. But please keep watching so that you watch how we do it exactly. So A is -3k minus 1k plus 3, and B is k plus 3, 3k plus 5. So the gradient between those 2 points, not the perpendicular bisector gradient, is the change in y over the change in x, which will be, doesn't matter which way around you go, as long as you're consistent. So 3k plus 5 minus k plus 3 over k plus 3 minus -3k minus 1. Cleaning that up gives me 2k plus 2 over, don't know what happened there, k plus 3k, so 4k plus 3 plus 1 plus 4. And you can see here that we can factor out 2 into k plus 1. And in the denominator, we can factor out 4. So we've got 4 times k plus 1, which makes us very happy because that means my gradient is equal to 1/2. And that tells me that the gradient for the perpendicular bisector will be -2. Okay, because those two things have got to multiply to -1 because the lines are perpendicular. So that means that the last thing I've got to do is to find the equation, is to find the midpoint. It's going to be -3k minus 1 plus, okay, something's about to happen to my stylus. I think I might need a new battery. Nope, what's going on? Oh. Okay, let's see if this is going to work. I think I just did the dishes and I think I just got a drop of water on my screen, which is a pain. There we are. So there's the halfway point for the x coordinates, and we do the same thing here. So k plus 3 plus 3k plus 5 over 2. Right, I strongly recommend that you actually do this written out instead of trying to do it in your head, because you're likely to muck it up under pressure. So we've got -2k plus 2 over 2, and then 4k plus 8 over 2, giving me -k plus 1 and 2k plus 4. And we know that the gradient is -2. Couple of ways to do this. You could do it as y equals -2x plus c, but I think it's probably easier here. Well, I've done it here by going y minus y1 is equal to m into x minus x1. So y minus 2k plus 4, which is my midpoint coordinate, is equal to -2 times x minus -k plus 1. Now let's clean this up. What do we get? Y minus 2k minus 4 is equal to -2x. Now be careful with this. I'm going to get plus 2 into -k plus 1, which is 2x minus 2k plus 2. So let's rewrite both sides, and happily we see that the -2k goes, which leaves me with y is equal to 2x plus, sorry, that should be a -2, -2x plus, yeah, definitely got water on my laptop screen, guys, sorry, -2x plus 6. So that's the perpendicular bisector. Hopefully what you're seeing is that these coordinate geometry questions are very doable as long as you're really confident with your basic skills. Okay, so that one had just about the same things as the one in yesterday's video. Perpendicular bisectors come up all the time, midpoints, gradients. The only thing we didn't really use here so far is the distance formula, and that's just doing Pythagoras with 2 points. Okay, thanks for watching.